Assalamu alaikum everyone. Welcome to mathematics. And today I'm here with another very recent paper of A levels CIs. Paper code is 9709, variant 13 of May-June 2025. This is for your pure maths 1. So let's begin with question number 1 that says a curve has an equation y is equals to 2x plus 12 over x square. Find the equation of tangent to the curve at point -2, -1. Give your answer in the form y is equals to mx plus c. So the curve could be at any point. We need to find the equation of this tangent at any point that is given to be -2, -1. Okay, so we are going to find the equation of this tangent line. So let's begin. We know about if we know what is the equation of any curve, then we can easily find the equation of tangent at any point by finding the gradient of at that point. If you find dy by dx, that will give you the expression for equation of tangent. That is what we know. So let's begin with the working. Our equation for the curve is y is equals to 2x plus 12 over x squared. So to find the derivative, why we are finding the derivative? Derivative gives you equation of tangent. Okay. Gradient of tangent. Actually, it gives you the gradient of tangent for that particular equation. So let's see. Y dy by dx will be, okay, first rearrange this expression, this equation, because it is not in that format that could be differentiated. So 2x plus 12, this x square cannot be differentiated unless it will be in the numerator. So by using the law of indices, if something is in the denominator, the power, when we shift it, when we take the shift this into the numerator, the power will become negative. Okay, so it becomes 12x to the power -2. Now we have to differentiate this. Dy by dx would be, derivative of x is 1, so any constant term multiplied with it will give you the same constant sum. So for derivative of 2x will be 2. So 2 plus derivative of any expression to the power n will give you nx n minus 1, means 12 is the constant, it will stay outside, and nx n minus 1 means power multiplied by the variable, and power will be 1 less, so -2 -1. That's it. So let's move on to the next thing. Okay, we can skip this part. This is just for your information. So 2 minus 2 times 12 is 24, x to the power -3. This is a general expression for your gradient of tangent, but like this could be anywhere. This general expression for this equation, what would be the equation of the gradient of tangent? Now if we substitute in place of x any particular point, like if we put x equals, if this is, for example, x is 3, this is x equals to 2, this is x equals to 1. So if we are going to substitute x equals to 1, then it will give you the value of gradient at this point. If you put x equals to 2, it will give you the value of gradient at this point. And if you put x equals to 3, it will give you the gradient of the tangent at this particular point. So we are being given the x coordinate of the point where we need to find the tangent. This is your equation, for example, and this is the point that is given to be -2, -1. So that means we need the value of the gradient at x equals to -2. We are going to substitute that. So at x equals to -2, the gradient value would be dy by dx will be equals to minus 2 minus 24, or we can rewrite this first in standard form. That would be minus 24 over x cube, 2 minus 24 over x cube. So solving further, 24 over minus 2 cube. So this will become minus 2 minus 24 over minus 8. That becomes minus 2 plus 3. So that comes out to be, okay, why we're taking minus 2? Oh, this is not minus 2. This is 2. Okay, so 2, because we are carrying forward the same, this 2. So this is the same 2. It's not the minus 1. Now we have to do 2 plus 3. So 2 plus 3 is 5. So this is the gradient of tangent at this point. Now we need to find the equation of the tangent. So to write equation of any straight line, we know by using point slope form. If we know one point and gradient, we can write by using y minus y1 equals m times x minus x1. So y minus, what is y coordinate of the point that lies on this line is minus 1. So substituting that equals 5. That is the gradient that we just found. M is actually the gradient of the tangent. Okay, so 5 and x minus, what is x coordinate of the point on the curve on the tangent line? Minus 2. So solving this all will give you 5 times x plus 2. We need to give answer in mx plus c form. So arranging this, y equals to 5x plus 2, 5 plus 10 minus 1, 5x plus 10, and this one will be subtracted on the other side. So we are left with 5x plus 9. So this is your whole working to find the equation of tangent line at any point for a specific curve. I hope you get it. Thank you.